Hello everyone, welcome back. I'm here with another tutorial. In this video, we're gonna run linear regression in Python. We will be working with the data set on California housing price that was launched and shared on kaggle.com. The main goal of this project is to predict the value or price of the house given some features of the house and the household in general. So if you want to come along with me, you can find the data set on kaggle.com. Let's get started and loaded Jupyter Notebook. I have written the codes here before and we just run them. So first we import packages that we need, pandas and numpy for numerical calculation, matplotlib and seaborn for plotting, and stat models and scikit-learn for statistical analysis and modeling. You see the list of packages here, and the ones that we will be using specifically in this example are the last 5 lines. So we run this cell to import them. And next, we're gonna load the data and looking at it before doing any regression analysis and see what we're playing with. Then we go ahead and format the data to the data that we need and clean it. And from then on, we go ahead and run the regression and we'll see how valid and accurate our solution is. So you see, we have 10 columns or 10 variables in total. And we're gonna call these columns in the next line by df.columns. So we have longitude, latitude, housing median age, total rooms, total bedrooms, population, household in the area, median income, and median value of the house, and location from the ocean. So, but we only want to predict the value of the house, which means that median value of the house is our target variable. Before running the regression, let's more dive into the dataset and clean it. We will get the information of the dataset by df.info, and as you can see, we have 20,640 entries in general. So let's see if we have missing values or not. We do that by df.isNull and also sum at the end to get the total number of missing values. We see that the total bedrooms variable has 207 missing values. In the process of getting rid of the missing values, we should know that dropping a part of the null values is okay, as long as it is not the large chunk of data. In such cases, we can also consider imputation. And here we drop the missing values by df.dropNo. In the next step, we're going to see some stats and visualize the data. We see the stats including mean, maximum, minimum, and quartiles. Then we're going to plot the distribution of the target variable. And as I mentioned, it is the median house value. We use histogram and label median house value variable on x-axis and its frequency on y-axis. You see, based on the plot, we have outliers, and then we calculate interquartile range for median house values. The code gives us the number 145,200. It is our IQR or interquartile range. So then we're gonna create the box plot of the y variable. The box plot indicates the 25th and 75th percentiles, and the line in the center represents the median. So these lines on the top and bottom represent the maximum and minimum values respectively, and any points beyond those lines are outliers. We will remove those outliers using selection in pandas. We define the upper and lower bounds and then remove outliers using these lines of codes here. Then we're going to do the same process for outliers detection in median income variable. And having histogram to see the distribution and box plot to see and detect outliers. Then we calculate IQR for median income and we'll get rid of the outliers. Now that we have cleaned the data, we're going to see the correlation between variables. In order to do that, we use heatmap from Seaborn, but we need to drop the non-integer variable, which is ocean proximity. You see the darker shades show higher correlations, so total bedrooms and households are very well correlated. You see total rooms also has a high correlation with total bedrooms and households, but total bedrooms has a lower correlation with response variable than total rooms. So to avoid multicollinearity, we drop the total bedrooms column. And now we're gonna check our non-integer variable and to see if it's correlated with other variables or not. To do that, we should do one-hot encoding. You see the ocean proximity island shows a logical correlation with the other encoded variables, so we drop it to avoid multicollinearity. And that was it. Now that we're done with data processing, we're good to go and build the regression model. First, we set the independent variables or features and by dropping the target variable, and then the dependent variable or target variable. Then we need to split the data into test and train to see if it works. And we do that using the train test split method in scikit-learn. We dedicate 20% of the data set for testing. In the third step, we are going to calculate the value of the rolling weighted least square, OLS, or ordinary least squares. It provides a global method of the variable or the process that we are trying to understand or predict. Also, it creates a single regression equation to represent that process. So we run these codes and here is the result. From the tables, we see tiny p-values for all variables in the t-test, which indicates that all of them are statistically significant. The standard error is large, that shows heteroscedasticity in the data, and the large condition number also indicates multicollinearity in the data set. So for now, we'll leave it here and go to make predictions. Using these two lines of codes, and using predict method and then call the predicted y. And now is the time to check the initial OLS assumptions, which are linearity, residuals being randomly distributed, and observations being independent or exogeneity, and lastly homoscedasticity. First, for checking the linearity, we plot actual values and predicted values, the latter on y-axis and the former on x-axis. So you see as the actual values increase, the predicted values increase as well. So it is linear. Secondly, we're gonna see if the residuals are randomly selected without any systematic patterns. And we plot the residuals on the scatter plot. We see that an almost even distribution in residuals on either side of the y equals 0 line, so they are randomly distributed. Thirdly, we check the observations for independency. You see by running these lines of codes that all of them are independent with 0 correlation. And finally, we check the data for homoscedasticity. We plot the fitted values against residuals that we have done it before. We plot it, and since the plot shows a random scatter of residuals, the homoscedasticity is fulfilled. Now we scale the data using standard scaler from scikit-learn to fit the model. Then we use linear regression method to make predictions and finding MSE, R-squared, and adjusted R-squared values. So from the results for the MSE and adjusted R-squared, we can say that the accuracy can be improved by using better models, And we can use other types of regressions like lasso, and that was it. That was the process of cleaning a dataset and running a regression model in Python. I hope you found this video helpful, and if you did, please give it a thumbs up. And I'll see you in the next tutorials.